Morning everyone, it's Wednesday, August 24th, around noon. I'm on number 12 here with Jayson, our Director of Agronomy and Grounds. Just thought it'd be a great idea to show you the way our new bunkers are constructed, and no one better to tell us that than Jay. So Jay, tell us, this bunker was last built in around 1999-2000. What's the big difference between what we're doing here today compared to back then?
Yeah, that's a good question, John. I think in the last 20 years, technology's advanced much like anything else in our worlds today. Sands back 20 years ago, nobody really measured the angularity of sand. And so the sands back in late 1990s were very rounded sands, and hence the word fried egg lies, and the sand would have a greater propensity to slide and move off our faces. Since that period of time, manufactured sand has become popular. And so all our sand that we're putting in these bunkers are angular sand, which allows that sand to bind to each other so it doesn't slide in heavy rainfall conditions. Also back in late 1990s, early 2000s, liner technologies really didn't exist to the level they are at now. And we're at the stage where the Better Billy Bunker system is the #1 system globally to rapidly move water through rain events.
So Jay, tell us about the construction of this bunker and what it's all about.
Okay, John, thank you. That's another good question. So with bunker construction today, it's a system. It's an incorporated system with drainage and materials. And primarily in this bunker, as you can see, you've got water sheeting into a bunker, which you want to avoid. But in this system, you have a compacted subgrade. Everything is stripped out of these bunkers as a hard shell. Our existing drainage lines need to be checked for positive movement of water. You'll see in this bunker here, underneath this gravel, it's 2 inches of laboratory tested gravel. The gravel is of a certain specification that meets the manufacturer's quality control standards. They apply 2 inches of stone throughout the bunker floor, from one edge to the other edge. You'll see in this bunker, it's hard to determine here, but the drain line is actually recessed. You'll see there's a slight dip in the drain, and that allows, when 6 inches of compacted sand is applied on top of this stone, right above the drains, it'll be closer to 9 inches. And the reason why that's important is because we're actually constructing a perched water table, like a USGA green. That extra depth will allow these bunkers to drain even more rapidly.
So Jay, I see 2 colors here. The one on the left is lighter, and then the one on the right looks a little bit wet. So what's happening there?
Okay, John, so yesterday afternoon, the KCM construction crew, they only applied the Better Billy Bunker binder. It's a polymer glue in essence. It's heated up to a certain temperature. There's a 3-person crew that come in here and they spray the floor very carefully. Now, there's 2 inches of gravel. You'll hear my feet moving in a second. You'll see how I'm sinking into this loose gravel. There's a lot of gravel on this floor and it's specked. Now, once that glue is applied, the glue goes about 1 inch deep into this. It supports 200 pounds. So it's locked in, however, it's still porous. And to prove that point, we'll do it later with a hose. I have a sample of Billy Bunker stone here, and I will just gently pour it through the stone. You can see it going through the stone like a shower.
So that allows rainwater to pass through, keeps your sand clean, and prevents contaminants from coming up from below.
That's correct. That's correct.
So one noticeable thing is these burlap bags. Tell us what that's about.
Sure, John. So the Burlap Bags is the system that they use here in Canada primarily. KCM are unique to this system. In the States, they'll use clay to form a shape. But in general, they cut an edge. This bag is 6 inches in depth, and generally this edge is 6 inches up to 4 inches, and they put 2 inches of stone. This bag is here to provide shape. It also is full of topsoil, which will allow the sod that goes over the edge, as an example, to knit into this edge. And the key part of the system is sand will come up halfway on this face, and the grass needs to be living, in essence, to keep everything locked behind. We don't ever want soil getting into the new white sand. So it's a mechanism to lock it in. The sod will be applied down to the stone. It'll be keyed in with staples. It'll be watered vigorously so it could heal. And then your sand will be coming up to this grass. Once you have heavy rain events, water will shed right into this drainage matrix. I've seen 3-4 inches of rain cause 0 issues. We'll have no contamination. Instead of spending 150 man hours repairing bunkers, we'll basically be able to go out and blow the bunkers and they're ready to play right away.
So one of your frustrations, I know, is when golfers exit the hazard from the high side and they take a big step on that edge and it crushes. So I can see the intricacy of the building and how much work it takes to repair those. So I can really see your frustration when golfers don't take the low spot in and out.
It does help to use the low area.
So here we are on green, right side bunker on 13. This one has our signature sand in it, which is the brand imported from Ohio. Tell us a little about what's going on here, Jay.
Okay, John. So this bunker is another step advanced from the previous videos we shot this morning. This is an almost finished bunker. You'll see there's a well or a berm that they've intentionally placed inside this bunker cavity. The reason for that is inside these bags, we still need finished topsoil and grading. There will be some contaminants that may end up in the sand. So this is an area where these spoils can be collected. They'll come through once the sod is laid and they'll take away any contamination. That becomes garbage. The rest of the sand is pure. The sand is in this bunker to protect the billy bunker polymer binder that we saw earlier. That polymer can heat up well above 130, 140 degrees on hot weather days. So they put the sand on top, it packs down on top of that gravel that keeps that billy bunker where it should be. And in fact, this is the most efficient way of doing these traps. Jayson have been doing this for many, many years. This sand, as John mentioned, is signature sand. It's a great sand. It has some good moisture holding properties. This sand will pack very well. This sand has been a tested sand that we've had on our test bunkers. The sand has been laboratory tested as well, so it marries very good with the gravel underneath. And the next step in this is depth of sand. I've got my little probe here, and what the construction company will do is they're somewhere around 5 to 6 inches compacted is what we want on our bunker floors. Certainly on the edges, 2 inches compacted. And so they've come in advance and they've put sand on this bunker, and there's a depth there about 9 inches. And then we'll come back through with plate tampers and rain and water and pack this bunker sand down over the next few months, weeks, and let Mother Nature take its course. And you'll see the bunker, becomes like a bunker you're used to, and it packs relatively quickly. So there's a drop of about 3 inches just there alone. And the finish will be great. The bunkers, for the most part, Dr. Herdston has brought them in a little bit. The entrance and exit on a lot of the traps are more accessible for all players right now. And a lot of the surface water he's trying to shed away from the bunkers when we do have those large rain events. So all in all, we're very happy with progress. We do anticipate the 11th hole, I believe, by the end of next week to be fairly close to being somewhat completed, but we'll leave that for later.
That's great. This is exciting, Jay. We're all looking forward to seeing the final product. Thanks a lot.
Thank you, John.